I'm hungry, but I don't know where to eat.
The canteen. Perpendicular. Parallel that thing.
And parallel to that, if you move it straight line, you'll find the canteen. You know what parallel is, right?
It's too cold. Will I ever get to the pencil?
Do not be afraid.
Who are you?
I am Mickey.
So basically, a parallel equation looks kinda like this. They don't intersect, and they go in the same direction. And when you have the graph, this is pretty much how you tell whether it's parallel or not. And they don't intersect, as you can see here, and they both go in the same direction, and they both slope the same way. But what if you don't have the graph? Then you focus on these two little equations here, and it's actually kinda easier to tell. So these two equations, they're in what you call y form. And this means that y is isolated as a variable on the left-hand side, while the other terms and variables are on the right-hand side. The first one is what you call the slope, or m. Keep that in mind because that's very important later. And the next variable would be b, or the y-intercept. And the slope is basically what direction the line goes in. And the y-intercept is what point in the y-line does the equation pass through. Basically, if you can tell whether it's parallel or not, is through the slope. Because remember that parallel lines go in the same direction. And if the slope, like here, if it's the same, then it's parallel. And if the y-intercept is different, then it is parallel. When you graph this, here's how it will look like. As you can see, the slope will be pretty much the same, and that means they would go in the same direction, while the y-intercepts are different. The first one, the y-intercept being 5, therefore it being a point of 5, while the second one being a negative 2, could be a negative 2. But wait, what if you only have one out of the two equations in the solution set? Well, it's about as easy as this. Confused yet? Well, it's actually not all that confusing. Here's an example. If you have something like this, they'll usually give you one out of the two equations and a coordinate to where the mystery equation passes through. And of course, it shows whether it should be parallel to or perpendicular to this equation. Now, before we get to the actual formula, we must remember that this is x times 1, or x sub 1, meaning that this coordinate represents where on the x line it is, and this one is y sub 1. So basically, the formula would look kinda like this. Y minus y sub 1 equals m times x minus x sub 1. Now, as you can see, the values could already be substituted at this point. So, it's going to be y minus 5 is y sub 1, so 5 equals, then what's our slope? Remember that this is a parallel equation, so the slope would be the same. So you just copy that here, so 4 times x minus 2 is x sub 1. And from there, you can begin solving. So basically, it would end up a little like this. So this is your solution. It is in y form and it has the same slope but a different y-intercept, as you can see here. And in order to check it, you may graph it if you want. So this is how to get a perpendicular solution. And this is a perpendicular set of lines. They're kind of different from what parallel lines are because, one, they have a point of intersection, and they're different from other intersecting lines because when they intersect, they form a 90-degree angle. And in order to show this, you have to show a square, though this one isn't very perfect. And that's pretty much how you tell whether a line is perpendicular or not with a graph. But without a graph, and you have just these two, remember that the y-intercept is always different. But when it comes to the slope, it gets a little confusing. You see, the slope of two perpendicular lines should be the negative reciprocal of each other. This basically means that they're switched around, reversed, and turned negative, basically. So since 3x is technically 3 over 1x, it will become negative 1 over 3x. This goes the same with 2x, which is 2 over 1x, and it becomes 1/2 x. And same with negative 3/4 x, it will become 4/3 positive. So yeah, that's basically how you tell if it's perpendicular using just these two. But again, what if you only have one of them? Okay, now the good news is you can use the same formula used in the parallel with what you have with the perpendicular. So this again would be x sub 1 and this would be y sub 1. And it would be y minus negative 2, which is y sub 1, equals, what's the slope? Remember that in a perpendicular solution set, the slope would be the negative reciprocal of this. So what's the negative reciprocal of 3x? Since it's 3 over 1, supposedly, it would be negative 1 over 3. And afterwards, it would be like x minus 3 is x. Now, you can pretty much solve for it. To get rid of 3 here, you have to multiply all the sides. So, 3 You don't have to add the negative one, but later on, you may need it. But we're not done yet because in the variable y still has a coefficient of 3. It has to be equal to 1. So we divide everything by 3. So cancel these out. This becomes negative 1 since it's negative to positive. So the final answer would be negative 1 over 3 minus 1, which corresponds to our original solution set, wherein it would be y equals 3x plus 3 and y equals negative 1 over 3 x minus 1.
Oh, I get it. Thank you, Matthew. Very well. I shall be on my way.